Okay, so let us now talk about two exotic binary star systems. You can say two exotic binary just systems. Let us talk about it. Two exotic binary systems. Okay, now we have already talked about the Roche-Loeb and mass transfer for a binary system. Fine. Now, when I am saying exotic, you will soon see. So, what I want to tell you, the first object, is it possible that I am looking at a star-like object and which has got a compact object in itself? Is it possible? You have studied stellar structure, stellar evolution. We have studied all these things, right? Now I am just asking you, is it possible that I am looking through a telescope and I am observing a star-like structure, say a red giant, having a white dwarf inside it? Is it possible? At first glance, the answer is no. Red giant and white dwarf, how can we have both? Again, red giant and a neutron star, how can we have both of them together inside a same star system? But the answer is, actually there are two things, a red giant and a neutron star, right? Now you see, in a binary evolution, suppose this is a neutron star, okay, and there is a main sequence star which is quite close to each other, and during the course of its evolution the main sequence star's envelope goes out during the red giant phase. So what can happen? Is it possible, such a thing? Of course it is possible. Now you might be saying, sir, when the star has started, the envelope has started growing, then there would have been mass transfer. Of course, there would have been mass transfer. But suppose the expansion of envelope, the rate is much larger than the rate at which the mass is being accreted onto the neutron star. Then what will happen? Then this will keep on expanding and we can have a red giant envelope which has already engulfed, say, a neutron star. And now if I observe through a telescope, what I will see is a red giant star which has got a neutron star inside it. This is an exotic binary star system. You have to understand. A single system cannot have this, right? Now, if we have a tertiary star system, then it is possible that we have got another white dwarf as well. 1, 2 and 3. And all three inside a single red dwarf system. This is also a possibility. Now these are all theoretical possibilities. James Webb Telescope and other instruments have yet to verify them. This in particular, a red giant star engulfing another star, or say engulfing a compact object like neutron star or a white dwarf. Now, so this is the first exotic binary star system I would like to talk about. Now, the next one is what is known as spider pulsar. I think in December this year, 2023, they have discovered more than 9 or 10 spider pulsars. Previously, there were only 1 or 2 were known, but now a large number of such pulsar systems are being observed. So, what is a spider pulsar? Basically, what we have is again a binary star system where one is a pulsar and another is say a normal star or say a brown dwarf. That's also a possibility. Say brown dwarf. Let's talk about this. Now the pulsar's beam, if it beams like this, then what? Suppose this is the rotation axis and this is the magnetic, right? So suppose the pulsar's beam is like this, then there is the possibility that the light during the spinning phenomena, the beam will fall on the surface of this brown dwarf. Then what will happen? Basically you are looking at a very energetic beam of gamma rays, charged particles, and as a result the atmosphere, the surface layer of the brown dwarf, they will be evaporated. The particles, huge heat is falling, right? Here they will be evaporated. But remember, the whole thing is rotating. It has got its motion. This object has got its own motion, brown dwarf. So as a result, this whole gas, they will not just escape. No, they will not escape. But they will actually form a sort of ring-like structure around. Okay. And using telescopes, we have observed this thing. So, a ring-like structure around a binary star system, where one of them is a pulsar, where the pulsar beam directly falls onto its companion object. Very soon what will happen? This will evaporate. So instead of this, very soon in future, what you can escape, you can think of, there is a very small remnant probably, its mass will be much lesser, and most of them will be just in this ring outside this binary star system. And we are observing this ring, we have observed this ring through which we have identified the pulsar. Because you will see through the telescope, what you will see a faint structure, and inside which you will see pulsing, which means that there is a pulsar inside this binary star system. And what is the origin of this ring? The origin is the atmosphere, blown up atmosphere, the blown up surface layer, which is now part of the ring. Same is happening for Saturn as well. Saturn has got many satellites, right? If you look into the outermost ring of Saturn, outermost ring, which you will normally not see. Only when the sun, Saturn is entirely able to block the sun, then you will see the outermost ring. The origin of the outermost ring is one of the satellites of the Saturn. There is water coming out of it. Interesting, boiling water coming out of it. So that water molecules, they cannot escape the system. They cannot escape the huge gravitational field of Saturn and its satellites. So they are outside forming a small ring because of the gravitational effect. They are forming the outermost layer outside the Saturn. Do check this. Okay, you can see in YouTube or internet also. The same thing is happening here as well. So we have observed we've talked about two exotic binary star systems.